You are listening to The Vocal Technologist. Spoken tech for your ears.
What if you managed a team of 24 eager developers who worked for free, never slept, but entirely ignored each other, occasionally leaked your API keys to the public, and, wrote 50,000 lines of code to solve a problem that really only needed 10?
Yeah, no, I would probably resign on the spot, or at least take a very, very long holiday.
Right.
But look, you are describing the exact reality of scaling autonomous AI agents. That is just how these systems operate.
It is a totally wild scenario, but it is happening inside engineering departments everywhere. So we are going to look under the hood of autonomous AI agent infrastructure.
Spot on.
Our mission is to pull apart the reality of scaling these systems without bankrupting the company or just completely breaking existing networks. We have got a massive stack of engineering blogs, security briefs, and research notes to unpack.
Yeah, there's a lot to get through.
Absolutely. We are going to explore how the infrastructure around these agents is maturing, the physical collateral damage these bots are causing to traditional network caches, and look, why throwing more automated workers at a problem might actually destroy the beautiful art of developer laziness.
It is a really fascinating tension, I reckon. We are moving from a world where AI was sort of just a stateless chat interface. You ask a question, you get a text response, to a world of continuous autonomous workers.
Yes.
And that fundamental architectural pivot is actively breaking the underlying systems we have relied on for decades.
Okay, let us start with the economics of that pivot, because the compute costs are staggering. I was reading through the engineering notes on Cloudflare, specifically their Project Think.
Yeah, Project Think.
Yeah, it is their approach to next-generation agent infrastructure, and they are pushing this concept of durable execution and persistent sessions. They are essentially giving every single agent its own identity and a dedicated SQLite database.
The sheer necessity of that architecture becomes pretty obvious when you look at how the web was actually built.
Right.
Traditional cloud architecture is completely stateless. A request comes in, a server spins up, processes it, returns a web page, and then just immediately forgets everything that just happened.
Which is brilliant for static content.
Exactly. Incredibly efficient for serving static files. But an autonomous agent is not just serving a web page. It runs in the background, executing really complex tasks over hours or even days. It needs a memory bank.
It needs to know what it was doing.
Yeah, it needs to know what API it called an hour ago and what the response was.
Because if it forgets, it has to start the entire multi-step process over again, which, that wastes an enormous amount of compute.
Precisely. So giving it a dedicated SQLite database means the agent has a persistent portable state.
Right, because SQLite is just a file.
Exactly. It is a file-based database, meaning it is lightweight and can move around. If the physical server node the agent is running on suddenly crashes or experiences a network partition, the agent does not die.
Oh, wow.
The orchestrator just wakes the agent up on another node. The agent references its own private database file, regains its context, and continues exactly where it left off.
Okay, and that brings us to the compute costs, which is really the massive bottleneck here. Because running traditional containers for these persistent agents is just, it is so expensive.
Oh, full on.
If you use a standard Docker container, it comes with an operating system kernel, networking stacks, this massive memory footprint. It is like, okay, imagine keeping the engine running on a massive delivery truck all day long, just in case you need to move a single box.
Yeah, that is a great way to put it.
You are paying for all that idle time, just burning fuel for absolutely no reason while the agent sits there waiting for an API response. But Project Think introduces dynamic workers, which rely on V8 JavaScript isolates rather than full containers.
And the mechanical difference there is absolutely crucial.
Yeah.
An isolate is just a single execution environment built on the V8 engine. It shares the same underlying processes as thousands of other isolates on the exact same machine.
Right.
Because there is no operating system overhead to boot up, an isolate can spin up in milliseconds.
And crucially, they cost zero when idle. So to use that analogy again, it is like the delivery truck instantly materializing only at the exact moment the box gets picked up, moving it, and then vanishing completely. You only pay for the exact millisecond the CPU is doing work.
Running millions of simultaneous agent sessions on traditional per-container costs is mathematically unsustainable. It would bankrupt most engineering departments overnight.
No kidding.
So these new primitives like zero-cost idle time and lightweight isolates, they're essential for the technology to exist at all. It is pure economic survival.
Okay, but I do have to push back a bit on how far they are taking this.
Go for it.
because they have this 5-tier execution ladder for these agents. It goes from basic tool use, like querying a weather API, all the way up to full operating system access.
Yeah, they do.
I have to ask, is deliberately giving an autonomous AI full operating system access exactly as terrifying as it sounds? Handing a bot the keys to the entire file system feels like asking for massive trouble.
Look, it certainly raises alarms from a security perspective, absolutely.
Uh-huh.
But developers want agents that can act like human engineers.
Right, they want them to do real work.
Exactly. They want agents that can read local files, execute bash scripts, install complex dependencies, navigate directory structures. You simply cannot do that in a tightly constrained text box.
Sure.
OpenAI is actually standardizing this approach with their new Agents SDK. They're rolling out sandbox execution and file system tools across multiple providers, including platforms like Vercel and Modal. The industry consensus is that agents need a complete operating environment to be genuinely useful.
Okay, but giving an agent full operating system access means it is not just sitting there waiting for a prompt, it is proactively scraping, downloading, querying, and that sheer unprompted volume introduces a massive physical problem for our networks.
Oh, heaps of problems.
The collateral damage is becoming very apparent, especially when it comes to caching and routing.
Yes, because human behavior on the internet is remarkably predictable,
Yeah.
and our infrastructure was built for that predictability.
It is wild to think about. Take content delivery networks, or CDNs. They rely on caching popular content closer to the user to save bandwidth. They use algorithms like least recently used LRU, which basically assumes that if a viral video was requested 10,000 times a minute ago, it will probably be requested again.
Correct.
But AI crawlers generate this high-volume, incredibly inefficient traffic. They ask for obscure, unique combinations of data, or they just scrape a decade-old forum thread in a matter of seconds.
And when an AI agent does that, the LRU algorithm sees a massive spike in requests for that obscure forum thread.
Mm-hmm.
The CDN assumes this data is suddenly highly popular, so it caches it all.
Right.
In doing so, it pushes out the useful data that humans actually want, like the viral video or the CSS files for a major homepage. The cache hit rates get completely destroyed, and the origin servers end up overloaded with requests that the CDN should have caught. Cloudflare is literally being forced to rethink their cache algorithms entirely just to separate human traffic from AI traffic.
Just to survive the bots.
Yes, separating those streams is the only way to keep the web functional.
And speaking of legacy systems breaking under the weight of AI, I have to point out the dry irony of the load balancing situation.
Oh, the round-robin issue.
Yes. The tech industry spent the better part of 20 years perfecting the round-robin load balancer. It was the absolute gold standard for distributing incoming network traffic evenly across a fleet of servers. Request 1 goes to server A, request 2 goes to server B, and so on. And along comes an AI and it completely breaks it.
Because round-robin is completely blind to context, which is fatal for AI workloads.
Yeah.
A traditional web request is stateless, so any suitor can handle it. But an LLM inference request is highly stateful.
Exactly. Traditional routing for large language models using round-robin degrades prompt cache hit rates from 90% efficiency down to almost nothing across multiple replicas.
It is brutal.
It is exactly like being in a restaurant kitchen where a waiter gives the first sentence of a customer order to chef number 1, the second sentence to chef number 2, and the third sentence to chef number 3.
That sounds like a nightmare.
It is. Instead of just letting the one chef who heard the whole order finish the meal, you end up with total chaos and wasted effort.
And the cost of that chaos is staggering. When you send a prompt to a large language model, the inference engine builds a mathematical representation of that conversation. That is called the key value cache.
Okay.
It stores the exact tensor computations for the tokens you have already processed. If the user sends their next message and a round-robin load balancer routes that message to a completely different server, that new server has zero context.
It is starting from scratch.
Exactly. It does not have the key value cache in its local memory. It has to recalculate the entire mathematical representation of the conversation from scratch before it can even begin to generate the next word.
Yeah.
That wastes immense compute power and just destroys your latency.
So I was reading through the engineering blogs from DigitalOcean, and they have come up with a highly specialized solution for this called precise prefix cache-aware routing.
Yes, that is a brilliant system.
I really want to unpack this because it relies on radix trees. My understanding is a radix tree is basically a branching data structure that compresses shared prefixes, kind of like how autocomplete works on your phone, mapping out common paths of text.
That is the right mental model. In an LLM context, the shared prefix is the conversation history. The radish tree maps out the exact sequence of tokens that have already been computed.
Right, so instead of dumb round-robin routing, the system dynamically listens to real-time key-value cache events from the inference engines.
Yes.
When a request comes in, the load balancer checks the radix tree, finds the exact physical server that already has that specific conversational prefix in its local memory, and routes the request there immediately.
It boosts throughput by over 100% because you are never recalculating old context.
Yeah.
You are sending the customer order directly to the exact chef who already started cooking it.
But okay, hang on. Does that not introduce a massive bottleneck at the routing layer?
How so?
Well, if you have a load balancer trying to actively maintain a global map of every single key value cache across thousands of servers in real time, surely the latency of just figuring out where to send the request starts to outweigh the benefits.
It is a valid concern, and it's exactly why this routing has to be so incredibly precise and lightweight. The radix tree operates entirely in memory at the edge, and it only tracks the hash of the prefix, not the full text.
Just the hash.
Yeah. The latency added by checking the radix tree is typically a few milliseconds, whereas recalculating a massive context window on a GPU could take hundreds of milliseconds or even seconds. The trade-off is heavily in favor of smart routing.
Okay, so we route them efficiently, but now we have agents navigating external APIs, which opens up a terrifying security hole. We need to figure out how to stop these highly efficient agents from leaking tokens or running up massive inference bills.
The security layer is the next major frontier. You have agents that need to use external tools, which means they need to authenticate with third-party services.
And that is where the model context protocol comes in. It is essentially the standard for how agents talk to tools. Cloudflare is deploying a centralized architecture company-wide to manage their remote servers for this. But the part that really caught my eye is their new sandbox auth.
It is very clever.
It acts as a programmable egress proxy to authenticate agents using zero-trust principles.
Historically, if you wanted an AI script to query a private database or a third-party API, you had to paste your secret API key directly into the prompt or into the execution environment as an environment variable.
Which is terrifying.
It is incredibly risky because a large language model is notoriously gullible. Through prompt injection, a malicious user could easily trick the model into printing its own API keys in its output, or secretly sending those keys in a payload to a rogue server.
But here's the brilliant part of sandbox auth. It completely removes the token from the agent environment entirely.
Exactly.
The AI just makes a normal, unauthenticated HTTP request out to the internet. But the sandbox intercepts that request at the network boundary. It examines where the request is going, securely fetches the secret API token from a secure vault on the server side, injects it into the HTTP header, and then sends it off to the destination.
Yes.
The agent itself never even sees the token, so it physically cannot leak it.
You keep the execution environment entirely untrusted, but you still allow the agent to perform authenticated actions safely. You are controlling the network flow outside of the model's awareness.
I love that. So clean. And then there is the cost side of things with Cloudflare Code Mode. I found this highly amusing, but it makes perfect technical sense.
The Code is fantastic.
They managed to reduce token usage by 99.9% by collapsing dozens of complex tool definitions into exactly two functions, a search function and an execute function. I initially compared it to tricking a toddler by putting all their toys into one big unmarked box.
That is pretty much it.
But mechanically, the reason it saves money is fascinating. Because if an agent has access to 50 different internal tools, you have to feed the massive JSON schemas, defining every single one of those tools into the prompt context window every time it thinks.
Yes, the input token overhead is massive. A complex JSON schema explaining how to use a deployment API might be thousands of tokens. If you pass 50 of those schemas on every single inference cycle, your bill just skyrockets.
Yeah.
By collapsing them, the agent just queries the search tool when it needs something, and the system dynamically retrieves only the relevant schema for that specific moment. Hiding the complexity from the AI saves massive prompt space.
But hang on, even with Sandbox Auth securing external calls and code mode saving tokens, you still have to worry about rogue agents inside your own network.
Definitely.
I was reading about Datadog jumping into this space with shadow detection. How does shadow detection actually work in these environments to catch unauthorized bots? If a junior engineer just runs a bot locally on their laptop, how does the network know?
So shadow detection monitors the corporate network gateway for unauthorized model context protocol servers. It basically analyzes traffic patterns and connection attempts.
Right.
The model context protocol has a very specific handshake and signature when it communicates over a network. If an engineer quietly spins up a self-authored experimental agent on their local machine and tries to connect it to the production corporate database, the gateway detects that specific protocol signature.
So it spots the handshake.
Exactly. It blocks it immediately because it did not originate from the centralized monitored architecture. It prevents shadow IT from running rampant.
And Datadog also released a code security tool specifically for this autonomous era. It scans AI-generated code in real time for vulnerabilities before it even hits the human review stage.
Because an autonomous agent can generate thousands of lines of code in seconds. Human reviewers simply cannot keep up with that volume.
No way.
Traditional static analysis tools, which are usually run during a continuous integration pipeline, are often too slow or generate way too many false positives. The Datadog tool acts as an automated, high-speed gatekeeper, catching injected secrets or insecure dependencies the exact moment the bot writes them, rather than waiting for a pull request.
Which brings us to the philosophical core of this whole infrastructure build-out. We secure the bots, we optimize the networks, but what happens to the human engineers and the actual code base when implementation becomes frictionless?
This is perhaps the most profound shift of all. The cultural and architectural impact on software development is massive. When you drastically lower the cost of producing code, the nature of the code itself changes.
There is an observation from Brian Cantrell that really stuck with me. He explores the concept of laziness lost. His argument is that good software design relies on laziness as a virtue.
Yes.
Engineers are inherently lazy in a good way. We want to create simple, powerful abstractions so we do not have to do the same repetitive, tedious typing twice.
A human engineer will spend 3 days thinking deeply about a complex problem just to write 10 elegant lines of code that solve it forever. The physical friction of typing forces careful thought.
Right.
Because typing out 50,000 lines of boilerplate is exhausting, humans naturally invent elegant frameworks to avoid doing it.
But large language models lack this physical constraint entirely. They do not get tired. They are not lazy. They will happily generate excessive, unrefined boilerplate code all day long. Are we losing the art of elegant code because engineers can now just brute force 50,000 lines of code in seconds instead of thinking through a clean abstraction?
The answer is a resounding yes, if we're not careful.
Hmm.
When you remove the friction of typing, you remove the natural pausing points where developers stop and think about architecture.
They just keep generating.
Exactly. The AI just bulldozes forward,
Oh.
creating massive, sprawling code bases that achieve the immediate functional goal but become completely impossible for humans to maintain later. AI should be used as a tool to support human abstraction, not to bypass it through sheer volume.
We are already seeing the weird side effects of this brute force approach. GitHub is pushing Copilot to explode unit test coverage incredibly fast, which sounds great on paper. But at the same time, they're introducing an experimental cross-model reviewer called RubberDuck. It is literally a second AI whose entire job is to critique the code written by the first AI. We are apparently at the point where we are hiring a second robot to supervise the first robot because apparently that is where we are.
It sounds humorous, but mechanically it is a necessary check and balance. You are dealing with adversarial models. The first model is a generative model, prompted purely for speed and volume to create the tests.
Right.
The second model, the critic, is prompted with an entirely different set of instructions. Its only goal is to find flaws, architectural issues, and unhandled edge cases in the first model's output.
It is a fascinating technical arms race, but it points to a deeper issue highlighted in an essay by Maggie Appleton. She points out that having 24 agents running at light speed does not solve the fundamental human bottleneck.
The alignment problem.
Precisely. The bottleneck in software engineering is rarely the typing speed. It is team alignment on what to actually build. If you have a team of human developers, each armed with 20 agents, generating code without shared context, you just end up with a chaotic collision of incompatible systems. One agent is building a Postgres database schema, while another is building a front end that expects completely different data structure.
It means AI must support human judgment, not replace it. The tooling needs to focus on collaborative shared environments. We need infrastructure that integrates planning, context, and intent before the agents even start typing.
Yeah.
Because without that strict human alignment, faster code generation just means you build the wrong product much faster. You achieve failure at an unprecedented scale.
That is a very sobering thought to end on. I want you to look at your own team and the systems you are building and ponder this. Are your new automated tools actually helping you build better software, or are they just helping you write technical debt faster than ever before? As the host of Vocal Technologist, I absolutely love pulling apart these exact tensions, and I hope this conversation gives you a fresh perspective on your own stack. Remember that chaotic team of 24 developers we talked about at the start? The ones working for free but completely ignoring each other. Just make sure you are not the one managing them. Keep questioning your assumptions, and we will catch you next time.
Spoken Tech for your ears.